वेलकम। अ, आज हम हमारी समाकलन गणित की सीरीज को आगे बढ़ाते हुए देखने वाले हैं रिलेशन बिटवीन बीटा एंड गामा फंक्शन। हम पिछली वीडियोस में बीटा फंक्शन गामा फंक्शन को समझ चुके हैं, उसकी कुछ प्रॉपर्टीज भी देख चुके हैं। ठीक है, तो आज हम देखते हैं रिलेशन बिटवीन बीटा एंड गामा फंक्शन। उससे पहले देख लेते हैं बीटा एंड गामा फंक्शन होते क्या है। तो बीटा फंक्शन नथिंग बट जीरो टू इनफाइनाइट, सॉरी जीरो टू वन और इनफाइनाइट एक्स टू द पावर m माइनस वन, वन माइनस एक्स टू द पावर n माइनस वन dx, where m and n greater than 0. This is our beta function. And what is gamma function? Gamma n equal 0 to infinite e to the power minus x, x to the power n minus 1 dot dx, where n belongs to natural number. This is our gamma function. Okay, now we will see the relation between beta and gamma function. So let's write the relation between beta and gamma function. बीटा फंक्शन में क्या रिलेशन होता है? गामा m इंटू गामा n अपन गामा m प्लस n. ओके, तो बीटा एंड गामा फंक्शन में ये रिलेशन होता है, इसे हम प्रूव करने वाले हैं. ओके, तो इस रिजल्ट को हम प्रूव करने के लिए एक स्टैंडर्ड इंटीग्रल का यूज करेंगे, जिसे हम गामा फंक्शन की डेफिनेशन के साथ ही देख चुके हैं और प्रूव भी कर चुके हैं. तो अगर आपको इसका प्रूव चाहिए तो आप देख सकते हैं, इसे हम गामा फंक्शन से डिराइव करते हैं. ओके, सो इट इज नथिंग बट अ डेरिवेशन ऑफ गामा फंक्शन. ओके, व्हाट इज स्टैंडर्ड इंटीग्रल? नथिंग बट अ डेरिवेटिव ऑफ गामा फंक्शन. ओके, इट इज स्टैंडर्ड इंटीग्रल गामा n अपॉन a टू द पावर n 0 to infinite e to the power minus x, x to the power n minus 1 dot dx. Okay, this is our standard integral. Let's rewrite it. So I can write it gamma n a to the power n 0 to infinite e to the power minus ax, x to the power n minus 1 dot dx. Okay, this is our nothing but the standard integral. Now we will multiply both the side with e to the power minus a and a to the power m minus 1. Okay, so what will we get? Gamma n into e to the power minus a to the power m minus 1 will be equal to a to the power n 0 to infinite e to the power minus a to the power m minus 1. And what we have in the uh, integration? E to the power minus ax, x to the power n minus 1 dot dx. Okay, so this is constant because this does not contain any variable, that is x. Okay, so we can write it out. So gamma n e to the power minus a to the power n minus 1 equal a to the power n plus, and this will be adding. So we can add because the base is same. So a m plus minus 1 and okay, integration 0 to infinite. Now we can write it e to the power minus a 1 plus x. Okay, now the base is same, and that's it, x to the power n minus 1 dot dx. Now we will integrate both the sides with respect to a under the limit 0 to infinite. Okay, so by integrating both the sides with respect to a under the limit 0 to infinite. Okay, so let's integrate 0 to infinite gamma n e to the minus a to the power n minus 1 dot dx. Okay, here sorry, this space will be less, so I will write it as 0 to infinite a to the power n plus n minus 1 dot 0 to infinite e to the power minus a 1 plus x, x to the power n minus 1 dot dx and dx. Okay, so I can write it gamma n because n is constant 0 to infinite e to the power minus a to the power n minus 1 dot dx. Let's first solve the integration with respect to a. So we will write the value of uh, independent of a out of this sign x to the power n minus 1. Okay, this is the only value that is independent of a. We can write it out of this sign because we are integrating with respect to a first. Now limit will be same, so there will be no question of dual integration here. Okay, so simply here 0 to infinite a to the power m plus n minus 1 and e to the power minus a 1 plus x dot dA dx. Okay, now I will assume that minus, sorry, minus not minus, a 1 plus x will be as y, let's say. So we can write this dA equal be y upon 1 plus x dot not y, only dy, because it is only y. So it is okay. Now limit will not be changed, because when the value of a is 0, y will be also be 0. Okay, and if a is infinite, so y will also be infinite. So let's put these results in the our equation. So gamma n 0 to infinite e to the power minus, what is here, a to the power n minus 1 dot dA will be integration 0 to infinite x to the power n minus 1 dot 0 to infinite, limit will be same. Now we have changed the value of a in the form of y, so we can write what is the value of a, y upon 1 plus x. So I can write here y upon 1 plus x to the power m plus n minus 1. Okay, now the value of e to the power minus y, e to the power minus y, because we have changed this value as y. And now what is the value of dA, will be dy upon 1 plus x and into dx, sorry, into dx. Now I'm not writing this, I will write this in the next step. So 0 to infinite, here x to the power n minus 1, I can put this value out of here, because this is independent of variable, that is y. So 1 plus x. Now what we have in the integration 0 to infinite, this is also independent of y, we can write it as here is 1 power and here is m plus n minus 1, that will be m plus n. Now what we will get under the sign of integration, y to the power m plus n minus 1 and here e to the power minus y dy. Okay, so and that is be dx. Now see, because with respect to x, this whole function is constant, because it does not contain any variable, that is y x, sorry, है ना. So we can write it out of this integration sign. So let's write it as integration 0 to infinite x to the power n minus 1 1 plus x to the power m plus n dot dx into, okay, 0 to infinite y to the power m plus n minus 1 e to the power minus y dy. Okay, I hope you understood, because it is constant for x. Okay, because it does not contain any variable, that is x here, and in this integrated itself the variable is y. Okay, and this term does not contain any y, so this will be constant for the purpose of dy. I hope you know the basic principles of integration. So now let's see, when we saw the properties of beta function, we also show a result beta mn equal to 0 to infinite x to the power of n minus 1, sorry, m minus 1, write it, x to the power m minus 1 upon 1 plus x to the power m plus n. Okay, where m and n less than 0. So we can apply this property here. Okay, the only difference is that here m and here is n. So by the properties of this function, we can write it as beta mn. Okay, because this is mn, we can write it as nm. The only difference is m and n, otherwise all is same. Now okay, and what is this, see this carefully, this is nothing but the gamma function in the form of m plus n, because in gamma function, what is the property of gamma function, gamma n, let's change the color, gamma n equal integration 0 to infinite e to the power minus x, okay, or x to the power n minus 1, that is dx. Now compare this with this formula, what will you get? The only difference is that we have m plus n at the place of n. So if this is gamma n, this will be gamma n plus n, simple. This will be gamma n plus n, And here what we have in the left side, gamma n into this property. Let's change this property also. So now, what is this? See this. This is also a form of gamma function. How? This will this the variable is a. This does not uh, have any effect because we have this function as gamma n. Compare this with definition. What is gamma n? 0 to infinite e to the power minus x to the power n minus 1. Okay, so it is e to the power minus a because variable is x here, so here is now the variable of a here, so here will be a, and a to the power m minus 1. Okay, so here n and here m, so we can write it as gamma m. I hope you understood. Let's move. So now what we get gamma m, and what we get is gamma m. Okay, gamma m is the here remaining here, and this value will be gamma m. तो हमें क्या मिला यहाँ पर gamma n into gamma m equals bmn into gamma n plus we can write it as gamma beta m n. So we have also, let's write first gamma n into m upon gamma m plus n. Okay, how, why we write gamma beta nm equal beta nm? Because
we know the property of beta function that beta mn equal beta nm. We have seen this property while we were discussing our beta function, so we can apply this property here. So what we will get, that beta mn will be equal to beta nm, and we can rewrite it as beta mn equal to gamma m into gamma n upon gamma m plus n, and this is our required relation between beta and gamma function. So we have proved the relation between beta and gamma function with using the standard integral. We use first standard integral that was derivative from gamma function, and also the definition of beta function, and with the help of these properties we have proved the beta and gamma function. So thank you, we will meet in the next video. Until then, thank you.